There are some pretty simple built-in libraries in Python for doing unit testing, and they can range from being used in very sort of small footprint ways to being kind of more refined and using more detailed information and style in them. We'll look at a little bit of these. So the unit test module in Python, which is built in, consists primarily of test cases, test suites, and test runners. So individual groups of tests to test some feature, larger groupings of tests that we can get larger sorts of results for, and then things for running tests. You can do testing with the unit test module using simply test cases in a single file. You inherit from the test case class. So here we see that test1 thing is inheriting from unittest.testCase. It has two test functions included in it. They do nothing at the moment. And then we have another class, test another thing. So this is an interesting note that there can be multiple classes defined in this one file. The file doesn't have to have the same name as the classes like in Java. They don't need to be inner classes and only one outer class. We've defined both of them here in the same file, and this is useful for our unit test because we then have our main function where we just call to unittest.main, which is a built-in main function for the unit testing module that does some work of grabbing test cases and calling to their functions to run the tests. Every method that takes only self and belongs to a test case class in the current module will get run by that unittest.main. So you see here that I've got test1 and test2 like before. They take self as an argument so that they are pointing to their own class and can have some of that test case inner workings sort of available to them through inheritance here from the unittest.testCase class. There's another function that has a different name, doesn't need to have test anywhere in it or anything like that, and it just needs to have self as its only parameter, and it will get called as a test as well. Helper will not, because helper does not take self as a parameter. If it took more than just self, it also would not get called as a part of the test case. So this is a way that you can write little helper functions that you can use inside of your tests, but that won't get called as test cases. And we don't have to do anything to sort of register these test functions or anything like that. And as I said, no funny naming convention that's required for them either. When methods reach their end without any assertion error being raised or any other error that's not handled, then they're considered to pass in terms of the test passing. We can use various different kinds of assertions that, if they fail, will raise assertion errors, and those belong to the test case class. So we say self dot because these are being inherited from the test case class in the class that we're writing here. So we can assert true for a Boolean. We could assert false for a Boolean condition. We can assert equals to test that two things are equal. We can assert that something is in some other object. So for instance, a value being in a list. If this function is allowed to return several possible values, then we can assert that it is in the list of those possible values that we knew were allowed. You can assert equality between more complex objects. So here it was just two numbers, presumably. But here we can assert equality between these two lists. And we can even assert that something is not an instance or is an instance of a particular type. So for instance, if I wanted to confirm that you returned floats and not integers from one of your functions, then I could use assert is instance, then your value, and float as the second argument. Because again, remember that types are objects as well, and so they can be passed in here as values to that assertion function. There are some built-in ways to do setup and teardown before each test or before each test case. So if we want something to happen before every function that gets called from our test cases, for instance, to open a particular file or make sure that file was closed or reset a variable to something, that kind of thing, we can do it in setup and teardown. Those will happen before each function that's called from our test cases. And so that would happen before test 1 and after test 1, and before test 2 and after test 2. Setup class and teardown class will happen only once for the whole class. So for example, I can set up this database connection, and that will happen once before test 1 or test 2 gets run, and then teardown class will happen once after both of them are finished. The time that's spent in these maintenance methods does not count against your total runtime, and errors inside of those methods do not count as failures in your tests, which is something to consider if you wanted your test to fail because the user's constructor for their different types was wrong and blew up when you tried to call it with correct values or that sort of thing. So you do have to be careful that errors in those methods won't count as test failures necessarily. They may cause your test to fail in some way, but it can be a little complex there to debug and figure out. We've so far only used this built-in unittest.main function, but it doesn't give you much control over how the results are interpreted or presented. It will simply tell you sort of what failed and what passed. And it doesn't let you do much with the classes themselves, the different test cases and stuff like that. So if you want a little more control, then you can create a test suite. Then you add test case classes and functions to that test suite. And so you can add tests one function at a time this way, for instance. You also can add test case classes to the test suite as a whole. Then we can also load tests from some test case class. And we can then run each test in the test suite and print out some information before or after each test or different things like that. Then we get an actual object that is a test result. When we are done, that will have all of our results in it. So we run the suite using that test result, and by the end, we'll have our actual results from running in it. So for instance, here, I've shown that if the whole test suite was not successful, meaning that at least one thing in it failed, doesn't matter whether it's 1 or 100 that failed, if something failed, will come into this body of the if statement here. So then we can split into categories. For instance, tests that failed because the asserts came out wrong, meaning someone had a wrong value that came up from one of the functions that was being tested. Then you can print those failures as the specific information for each of those. Let's say ones that had errors. I don't want to tell you one by one which those were. I just want to tell you how many of them errored. So I could just say 5 tests errored or something. Obviously, this is not the most informative, but it's an example of the kind of thing that you can do if you dig a little further and you use a test suite, which then gives you a test result, and you can look at things like which tests failed, which tests had errors, etc., and dig deeper into those. You're also able to get information from each of those test case classes. For instance, if you kept a counter of something in those test case classes, if you use a test suite and you don't just call to unittest.main, you're going to be able to see those counter values or different things like that. And so I've used this at times for scoring and assigning scores to results from test cases. You might use it for keeping track of how many times a particular function of yours was called inside of those test cases or different things like that. So the built-in unit test module in Python has some pretty straightforward ways that you can do some basic testing of your code. And if you want to dig a little deeper, you can build up your own test suites and you can analyze the results in a little more interesting and informative ways as well.